Can you hear?
Oh, yes. Wait, just a second.
Okay.
Excuse me. Nice. Oh, okay. Thank you. So, we'll just continue. Uh, I just like we'll start by listing down some Barry formulas. They are like quite easy to prove, so I'll just not prove them right now. Maybe later we can see why they should turn out to be the way they are. I hope everyone is comfortable with what was covered in the first barycentric class. If not, you can just like stop me anytime and ask. Feel free to interrupt. Okay. So the first thing is that if you have points A, no, A is taken, sorry. The points P, let's say x comma y comma pz, and points Q, then the distance PQ square. So we what we call is this is a displacement vector PQ. Uh, this is given by, and these should be in the homogenized form, like they should add up to one basically, not the unhomogenized form for to calculate distances. So the displacement vector we can call it is qx minus px, comma qy minus py, comma qz minus pz. So like let's just denote this by x comma y comma z, where they should like add up to 0 for the displacement vector. Then pq square is given by minus a square yz minus b square uh, zx minus c square xy. Okay, so this you can prove, I think, just by taking the vector form and mod like just take the mod thing. So you have like this. After that, you have the barycentric circle. So any circle in Bary takes the form. Okay, so what in a plane, how much degree of freedom does a circle have? Can anyone quickly tell? I'll just repeat my question. So in a plane, if you want to like locate a circle or want to draw a circle, how many degrees of freedom do you have?
Two.
Are you sure? Because how to, can you like elaborate?
Uh, I have to choose a center and a radius.
Okay, so center you are choosing in 2D plane, right?
Okay, so three.
Yes, exactly. Three. So one way you can think of it is that you have to choose the center in 2D plane. So one for x coordinate, one for y coordinate, and one for the radius. That gives you three. Another way to think about it is in coordinate, we had know the circle formula is x square plus y square plus 2gx plus 2fy plus c. So you have g, f, and c. These are like three degrees of freedom. And also like just like choosing any 3 points, you can just like okay, no, this is makes sense. Never mind. So okay. Yeah. So you have this. So like can you expect how many variables do you need in a barycentric circle formula? Okay, so like should be three basically. This is just because if you choose any 3 points at random, then you should get a unique circle. So and there exists a circle, it is unique. So if you have to substitute those points into the equation, you will get three equations in three variables, and they should have a solution. Like it should not be more, shouldn't be less. So you should have three things. Just erase this thing. Okay, so in barycentric we have the formula minus wait sorry minus a square yz minus b square zx minus c square xy plus x plus y plus z times I'll just write, okay, I zoom out. Okay, so this is x plus y plus z into ux plus vy plus wz is equal to 0. These are like variables which you can vary and get different equations of circle. Also, why is it beneficial to write it in this manner and not make this plus and this minus? Is that if this is a given circle, the power of any point P, you can just substitute its coordinates in homogeneous formed in the equation of the circle, and you can get the value. Also note that this equation for the points on the circle, this equation, you can, if you want to check whether the point lies on the circle or not, you may or may not, you can also take the unhomogeneous points because these are scalable. It's a homogeneous equation, as you can see. Yes. So we have this thing. One more thing that I don't know how much it's required, but it's good to know. Is it that if you have a displacement vector PQ and you have a displacement vector Mn, I don't know. Then PQ perpendicular to Mn, if and only if you have a square into y1 z2 plus y2 z1 plus b square into what is this? X1 z2 plus x2 z1 plus c square into x1 y1, sorry, x1 y2 plus x2 y1 is equal to 0. Also wait, sorry, I forgot to mention these ABC are the side lengths. I mean, okay, I should have mentioned it long ago. ABC are the side lengths. So when you are doing with respect to a triangle, so you have BC is equal to A, CA is equal to B, and AB is equal to C. So these are the side lengths, all the small ABC. Okay, so this was the part about the barycentric thing that was left. I will now digress a bit and like talk something about non-homogeneous coordinates.
Can you just show
So
the part on top? I just missed it.
yes,
Yes.
so like should I repeat anything or?
Yeah, the vector PQ.
Yeah, sure. So if the P and Q are these points, coordinates are in homogeneous form, that is they sum to one. Then the displacement vector PQ, like we call this as displacement vector. PQ is given by QX minus PX, QY minus PY, QZ minus PZ. So we just denote this by XYZ, like just for the sake of convenience of writing. Then the distance PQ square is given by this formula. Did you get it?
Yeah.
Yes.
Cool. Okay, so I'll just not digress a bit and talk about non-homogeneous coordinates. Okay, so can someone just quickly, just to revise, what were the non-homogeneous coordinates? What did non-homogeneous coordinates mean in barycentric?
Scaled, which have a scaling to the homogeneous coordinate
Yes,
multiplied
exactly.
by scale factor.
Yes, so we so we right now we were dealing. Oh, no, we should not use A, B, C. Okay. So we were now dealing with x comma y comma z such that x plus y plus z equal to 1. So we now just replace this by thing x plus, oh sorry, not plus, x, y, z. So this is equivalent to saying x by x. Okay, right now we will just assume x plus y plus z not equal to 0. We will come back to this later. X plus y plus z, comma y by x plus y plus z, comma z by x plus y plus z. So as you can observe that x is x, y, z. This is same as saying lambda x, lambda y, lambda z for all lambda. It's like just like lambda gets cancelled here basically. So both of these correspond to the same point. Okay, so these are not so non-homogeneous coordinates. We understand that we can scale them without changing the actual interpretation of that point. So are the okay, so let like we'll just digress from barycentric a bit. So just if we get back to the coordinate system in the 2D. So we have this thing, and then we have any point x comma y. Are these non-homogeneous?
Yes.
Are you sure? Like, are you sure you can scale them?
If they sum
Oh wait,
to
no,
one,
not that.
no.
Sorry, someone is saying something.
No, like I was just agreeing with him that
Okay, so I'll just say, so if you have 1 comma 2, let's say, and then you scale this by a factor of 3, so you have 3 comma 6. We know that these two are in the same points, right?
Yes.
This is like 1 comma 2, this is like 3 comma 6. So these are like, obviously these are different points. So what we now have is that these are not the same points, obviously. Okay, so now what we do is we add a third scalable vector z. So we now denote each point like by three coordinates x, y, and z, and this will correspond to the so if I translate back into this form, it will correspond by to x by z. Okay, right now I'll just assume z not equal to 0, x by z comma y by z. Does this make sense? So are now these scalable? So if I like multiply this by any lambda, this will correspond to lambda x by lambda z comma lambda y
Yes, so
by
this will become scalable, yeah.
yes, so that is same as x by z comma y by z. Okay, so this is scalable. So this is another way to use the coordinates. So what is the interpretation of this, or how can you visualize this sort of? So you can visualize these. So basically by this, I just allow z equal to 0 for the time being. We'll see later that why it is allowed. So these are just like coordinates of the r cube minus 0 comma 0 comma 0. So we'll see later why this is not allowed, even though we can take something like 1 comma 2 comma 0. So you can interpret this as lines in 3D. Like if you have something like this thing, then from origin, so if you have, let's say, 1 comma 2 comma 3, and then you have 2 comma 2 comma 1 2 comma 4 comma 6. So basically these two are the same point because you just scaled them. So these you can represent by the same line passing through the origin. Is that okay?
yeah, yeah.
Yeah, okay. So each point here you can represent, or I mean, let's say each triplet you can represent by some line in 3D passing through the origin. Yeah, okay. So this was sure. Wait, this is okay. Yeah. So if let's say we are dealing in this coordinates, also note that so when we are using barycentric is basically this form. Just we have defined them separately. So generally, when we are talking about non-homogeneous, they will apply to everything, even the barycentric, because just we are talking like we are just interpreting it differently. Basically, it's the same thing. Yes. So now. So let's say we want to talk about some equations of figures in the non-homogeneous coordinates, like in the barycentric, let's say, or anyhow in here also it's fine. So you have some non-coordinate system, and then can you have an equation like this? Like let's just say the coordinate normal circle equation. Do you think this equation will still can like anything of this form can still be used in the new systems?
I don't think so.
Why?
I think all the xy's should be of the same degree.
Yes, exactly. So the equation has to be homogeneous. That's what you mean, right? So because if let's say, okay, wait, I should have had some set term here. Let's say let's set square or something. I mean, yeah. So if we have, let's say, x comma y comma z satisfying this thing, and now if you so now this point we can also identify lambda x, lambda y, lambda z. right? By some other transformation. So this point, this system should also satisfy the same thing. But if you just substitute, let's say, okay, wait, I'll just like get back to, I mean, I'll just use Barry notation for the sake of understanding. So I'll just make this dots. So if you substitute back here, even this should equate to 0. But if you have a non-homogeneous equation, like let's say you have x square plus x equal to 1 or something like that, then if you multiply by any lambda, you get that lambda square x square plus lambda x equal to 1. No, like clearly this won't hold for all values of lambda, right? On the other hand, if you have something like x square plus y square plus 2xz, I don't know, I'm just writing random stuff, that equal to 0. Now, if you like x comma x y z, if you just replace this by lambda x, lambda y, lambda z, then you observe that so now when you observe, you can just take like lambda square common from everything, and you just get the same equation again. So this satisfies this if and only if this satisfies the equation. Is that clear?
Yes.
Nice. Okay. So we got this stuff. So the equations that we are dealing should be of this should have the same degree everywhere. So like the constant does not exist. It should like always equate to 0. That's why if you observe, our equations in coordinates are of the form like ax plus by plus c equal to 0. But in barycentric, we always use things like ux plus vy plus cz equal to, plus wz equal to 0. There is no constant term. This is a homogeneous equation. But this is not homogeneous. This is a cold equation.
Wait, is this because that c into 1 is there? So like because we just shorten the x comma y comma 1 into x comma y in coordinate system.
Yeah,
of
yeah. So
barycentric.
like if you replace this by lambda x, lambda y, so but this one will still remain 1. So you can't just cancel lambda from everywhere, right?
Yes, so we add that, yeah.
Yes. Uh, that is correct. So we have this thing. Now if we have okay, so now we will just discuss some things about, so now we will observe what happens when in barycentric you have x plus y plus z equal to 0, or in similarly analogous in the coordinate thing you had z equal to 0. So does everyone here know what is the projective plane?
Yeah.
Yes.
Yeah, sure. Nice. Okay, so just to recap, so you have points and you have lines. So every two lines, so so each line in the, like it's just a normal plane, each line you add a point at infinity along that direction, and then there is the line at infinity. So that's basically the RP square. So there exists unique line passing through any 2 points, and there exists unique point belonging to any two lines. Yes. So now what we do is, so I'll just define this in the sense of barycentric thing. So if you have something like in the system, if you have x plus y plus z equal to 0, this you define as the point at infinity. Basically x plus y plus z equal to 0, you define as the line at infinity. How do you do this? Okay. Okay, just like ignore this. So this you define as the line at infinity. So any point satisfying this thing must be some point at infinity along one direction, right? So we say that, so in barycentric we can now define parallel lines. So we can say that two lines, let's say L1 and L2 are, or let's say it's like U1 x plus V1 y
Oh, if
plus.
the intersection lies in the line at infinity, then they're parallel.
Yes, yes. So U1 x plus V1 y plus, how do I write? What's this W1 say? equal to 0 and u2x plus v2y plus w2z equal to 0. So if these three things u1 v1 w1 u2 v2 w2 and what and yeah and 1 comma 1 comma 1, if these are linearly dependent, then we can ensure that this is the point at infinity. Then L1 parallel to L2 basically. Is that clear?
What do you mean by linearly dependent?
Okay, so by linearly dependent, I mean that there exists some non-trivial. Okay, so how do I say this? Wait. Yeah, okay. So if you define that there exists some lambda1, lambda2, and lambda3, like not all zero. That's the trivial thing. Such that this first thing. So I'll just say that this is L1, L2, and L infinity. So that lambda1 times L1 plus lambda2 times L2 plus lambda3 times L infinity is equal to 0. Then these are called to be linearly dependent. Did you understand?
It's we're multiplying each of them by a scaling factor and adding it and seeing if they all
Yeah, yes,
are
yes,
0, 0, cos 0.
yes, correct. So yeah, is that clear? So basically, by some linear combination of this and this, you should be able to get this thing, or vice versa. Like for some linear combination of this, oh, let's go. Okay, so as some linear combination of this and this, you should be able to get L2. For example, if you have, I'll just give an example. If you have, let's say 3x plus 5y plus 4z equal to 0, then this line will be parallel to, let's say 5x plus 7y plus 8z equal to, no, sorry, not 8z, 6z. Is that correct? Yes. Do you see why these two lines should be parallel in barycentric?
Yes.
Nice. Okay. So just because, so this is L1, this is L2, you observe that L2 minus L1 minus 2 into x plus y plus z is equal to 0. So any point satisfying both the equations of L2 and L1 should also satisfy x plus y plus z equal to 0, and hence it must lie on the line at infinity. Okay, now I'll just give a sort of task or something. So if you have some point P, let's say x is to y is to z, such that x plus y plus z equal to 0, of course, show that uh, it is a unique point at infinity. I mean, so that by unique, I mean that it is the point at infinity along a unique direction. So I'll just write unique directions pointed. For example, like if you have this point, it should always be a whatever lines pass through it, it should always be like a set of lines. It cannot be a point at infinity along two different sets. Do you understand?
Okay, so if any,
Yeah.
so like if A is parallel to B and B is parallel to C and they all three pass, then A is parallel to C suffices.
Wait,
If we have A is parallel to B line and B is
yes.
parallel to C line and they all three pass through this point P, then it suffices to prove that A is parallel to C. Am I correct?
Wait, I think that is not actually what I mean. What I mean to say is, so you have this point P for like for right now, just forget that just for right now, just forget that anything about line at infinity P and infinity, just that it satisfies this thing. So if you want to show that it belongs to line, P belongs to L1 and P belongs to L2, where L1 and L2 have L1 and L2 are not equal to, let's say, line at infinity, like they have a good equation. Then you want to show L1 parallel to L2. That's the thing. And by parallel, we right now saw that there exists some lambda1 L1 plus lambda2 L2 is equal to x plus y plus z. So these are linearly dependent. Is that clear now? Or should I is that?
Yes, yeah.
Right, so we're already given that for P, it satisfies the equation of L1, it satisfies the equation of L2, and it satisfies like 1, 1, 1. This x plus y
Yes.
plus z equals 0.
Yes.
So then if they were not to be linearly independent, then we'll get that it has to be 0. Like it has to be 0, 0, 0.
Yes. Exactly. So just to recap what she said, so if let's say L1, L2, and I'll call this condition as L infinity, if these are not linearly dependent, then you will get a unique solution. Like you will get some x plus y comma z solution, which is unique because three equations, three variables. But you know that this has to be independent under scaling. So this has to be like equal to lambda x comma lambda y comma lambda z. But this can only happen if it's 0 comma 0 comma 0 thing. If so, you get that p should be equal to 0 comma 0 comma 0. But like mentioned at the start that we don't take this point at all. I mean, that is exactly because we don't take this point because this is not actually scalable. It's like a fixed thing. Did that make sense?
Wait, can you just like say it again?
Yes, so let's assume that P satisfies the equation of L1, L2, and L infinity. So if these three things were not, so basically you have these equations, right? U1x plus U2y, sorry, plus V1y plus W1z equal to 0, U2x plus V2y plus W2z equal to 0, and then you have plus y plus z equal to 0. So if these three things were not linearly dependent, using these three equations, you would get a unique solution x, y, z.
Correct.
Satisfying this thing.
Or that'll be 0,
But
0, 0, yes.
yes, it has to be 0, 0, 0 because even scaling should not work. But
Correct.
we do not include this point in the thing.
Oh, okay. Okay, got it.
Yes. So we have that every thing is just so I'll just like demonstrate with an example. So you can basically consider any linear equation among these, and it should be the point in infinity along that line. So for example, if you have, let's say, 1 is to reduced to minus 4, let's say. So you can just like say it as x plus, I don't know, let's say x minus 3y plus like 1 minus 8 minus 2z equal to 0. I hope that is correct. Yes. So you can just say that P, the family of lines which are like parallel to, I mean, parallel to the, which are in the direction of the point at infinite P. So this point P is some point at infinity. And so the family of lines which are at some point at infinity along this line can be given by just x minus 3y minus 2z plus lambda times x plus y plus z. These are the family of lines, family of parallel lines specifically along direction of P. Is that clear? Should I repeat or is that clear?
So lambda is just shifting the line, right?
Oh yes, lambda is just the shifting the line. True. Lambda is a parameter. And so all of these, so these are like a family of parallel lines, and they differ by some scalable multiple of x plus y plus z. Does that make sense?
Yes, yeah, that makes sense.
Yes. Okay. So this is what we had. Now one more thing. So in this thing, uh, so note that. Okay, so I mean it's a different thing that we are starting basically. So you can also visualize these in sort of dual forms. So for example, point P has the, okay, how do I, okay, so here not T will be a parameter. So any point P, you can write it as f of t is to g of t is to h of t. And f comma g comma h are some functions or basically polynomials, let's say for now, with no common roots. So any point P, you can represent it like this. Or I mean, okay, sure, let's not go there. It's like sort of moving there. We can just like remove this parameter. How do I erase? Yeah, okay, so any point P you can identify by saying, okay, now I can't stop erasing all these languages. Wait, give me a second. Okay. So any point P you can identify. Oh, yeah. So any point P you can identify as x is to y is to z, that we know. Similarly, any line also you can identify as, let's say, u is to v is to w. So what are these u, v, w? So if L has the equation ux plus vy plus wz, then you can identify this line by saying u is to v is to w. Note that this line coordinate is also scalable, because like by even taking lambda u is to lambda v is to lambda w, you are going to get the same line. Is that okay?
Yes.
Okay. So even this is scalable. So now what interesting thing to do is, so we can identify each point by a set of triple and each line by a set of triple. So now one thing to observe is you can just you can like how do I say this? So you can reframe the incidences and things. So if P belongs to L, if and only if P dot L equal to 0. So you can imagine this as vectors sort of. And now so P dot L is equal to 0. That is just the condition ux plus vy plus wz equal to 0. Is it okay?
Yes.
Similarly, if you have P1 comma P2 lines, then the line P1 P2 will be given by P1 cross P2. So if you just take the y z minus w, I mean this should be w by w. Okay, not if using the difference again. So it can be like w y minus v z and sort of stuff for P1 cross P2. Oh wait, I mean y1 z2 minus y2 z1 things for 2 points. And similarly, if you have L1 comma L2, then the point of intersection of L1 comma L2 will be given by L1 cross L2. Does that make sense?
Yes.
Nice. So in this way, it's very good to imagine. So the theorems or things where we usually take duals in projective geometry. You can imagine it this way because so every point and line you can just like sort of assign bijection or something. And the incidence part is and incidence part and the line part are just these things which will still be preserved. So did that make sense? Like, did that make sense what I said? Or should I wait? I'll just reframe it better. So okay, so let's say if you have p x comma y comma z and sorry, this is to y is to z, then you can just like sort of okay, no, I mean it's fine. So I'll just give an example. So just consider like the Pascal and Branken thing. So what Pascal states is that if you have any conic, then take any 3 points here, 3 points here. Oh, wait, I messed it. Did I again miss something here? Yeah, okay, so these points should be collinear. And if you just take the dual of this, so that is like just taking the polar stuff with respect to conic, you will get that if the conic is tangent to 6 lines. Okay, I don't know how to draw this. And there is some conic which is tangent to all of these, then you will get that a diagonal circumference. So basically points and lines behave the same way, you can just swap them. Does that make sense? So that is why like in the incidence is very, see that the incidence thing is mutual. I mean, it's not like point and line are different things. So point belonging to line is same as like is equally same as saying line passes through point. So this is the incidence condition. And so if you want to like draw line through 2 points, if you take the dual of this, that would be just taking 2 lines and intersecting them at a point. So basically this line goes to this point goes to this line, and this point goes to this line. Does that make sense?
Yes.
Nice. Okay. Yes. Okay. So this was what the digression was about. I will now get back to barycentric. One more thing before we start to do problems in barycentric. So there is something called Conway notation. So if you see, we'll just like derive this. Let's say if you have a triangle, what do you think the barycentric coordinates for H? I mean, you can just write them in the non-homogeneous form, like something is to something is to something. Okay, what is the most obvious one?
Isn't the barycentric coordinates for orthosymptotes something very complicated?
Yes. So okay. So basically, if you just like do this by standard techniques, it should come out to be tan A is to tan B is to tan C. Wait, am I writing? I mean, just
Yes.
like observe BD by DC is equal to tan B by tan C. Oh wait, did I miss that one? Oh no, it's correct. Right? Yeah, it's fine. It's fine. It's probably fine. Is it tan A tan B tan C, 1 by tan A 1 by tan B 1 by tan C? Wait, let's look at this. Let me just like check this one. I think I'm confused.
Isn't it actually like BD by AD is equal to cotan of B? Because AD is the opposite side.
Oh, did I? Oh, sad. Okay, right. That makes sense. Sad. I messed up. Wait, wait. Okay, so this is like chord. This is also like chord. Okay, then that makes pretty good sense. Then you get this is tan based tensor. Yeah, so this thing is actually correct. Yes, yes, answer that. Okay, so you got that H is like tan A is to tan B is to tan C. Similarly, you can also get O as sine 2A is to sine 2B is to sine 2C. But like it's obvious why angles are not very good. I mean, if you are like bashing in Barry, how would you know what the angles are, obviously? So what we do is we sort of improvise. Now, so what you can see is okay. Let me go here. Um, so I just define what the Conway notation is, and we'll get back. So by Conway, what they means is like you define SA to be b square plus c square minus a square by 2. I think it's by 2. And SB and SC similarly. He defines some random thing about SY theta or something. I don't really recall what that is because I have never used that. We'll just like if we encounter, we'll check it. And you define this similarly. Then now what you get is that so you can write tan A as wait just a second. Okay. So now what we intend to show is that H can be written as SBSC is to C is to SSB. Equivalently, this is like 1 by SA is to 1 by SB. Okay, can people try to show this? Okay, so I'll just say this. This is basically cosine rule. So you have tan A is equal to sin A by cos A. That is like equal to. So I'll just like ignore the what do you call constants. Like I'll just ignore that 2r because it just gets everywhere. So we can just ignore it in the due to we are only interested in the ratio. So I'll just ignore that 2r. So this sin A would be 1 by A. Oh, no, sorry, it's like A. So ABC by b square plus c square minus a square by 2. Does that make sense? This is just cosine rule. This is 2bc and so it becomes abc. So we can just cancel abc from everywhere and you get h is 1 by sa is to 1 by sb is to 1 by sc. Does that make sense?
Yes, but do all the old, results we proved also hold in this Conway's notation?
What do you mean hold results?
Like the
Can you
previous, like the line and the
wait, this is like we are not
circle.
introducing any new sort of chords. This is just like notation. So you
Okay.
can
Oh,
also
you
write.
just defined it. Ah, yeah, I got it.
Yeah,
So,
you can just write h explicitly as b square plus c square. Oh wait, yeah, 1 by b square plus c square minus a square is to 1 by
yeah.
c
Oh, okay.
square plus
That
b
way.
square
Yes.
minus
Correct.
whatever. Yes. So we have h is congruent to SBSC is to SASC is to SASB. Similarly, you can show that O is a square SA is to b square SB is to c square SC. I'll just skip that for this. I don't know. This may be useful, but I have not really used them. But like, if you see someone like Pranav, he just like very god at Barry, he might have used this. I don't know. Why is this not straight? Okay, so we have this. Okay, so that was like typically what the theory I had in mind. We can now like now delve into some Barry Bash problems. Okay, I am going to be a bit biased here, and the first problem I'm going to take is my first problem in Barry. So this was the first thing I had Barry bashed. So it may also be like wrong. I don't know. So we'll just like see. Can you see the question? Can you see the question?
Yes.
Yes.
Yes. Okay. So this is IGO 2024 or 2025, right? What was the I mean whatever last year he won. You can try this for some time. I mean, just like the content basically. I don't expect it to like bash in 5 minutes. I just need ideas for the bash. Oh, wait, it's selected.
Can we say something like the smaller equilateral triangle will be symmetric sort of, and then we just
Yes,
the areas.
yes. That is what we are going to do.
Yeah, so then if it's
How is the figure? Okay, it's like this, I think.
oh wait, I didn't realize it would be
What?
oh I thought I had for some reason thought it would be a different sort of configuration, like medial triangle configuration. And then it has to
Um,
be. Okay, I see.
yeah, because even XYZ has to be equilateral, no? And they have like all equal areas that is given. Oh, okay, wait, one thing I should have mentioned. I will write this somewhere. Wait, there is some section about making space. Okay, yeah. So one thing, it's like just another thing I forgot to mention. If you have P as x comma y comma z, I mean x1, y1, z1, it's a P1. P2 as x2 comma y2 comma z2. P3 as x3 comma y3 comma z3. These need to be in the homogeneous form. Then I divided this, I denote the area. This is given by the determinant x1, y1, z1, x2, y2, z2, x3, y3, z3. Okay, yes, I think that's how you derive the equation for line. I am not, I'm not really sure. Yes, yeah, that is how you derive the equation for line. You equate this to 0. Is everyone okay with this?
Yes.
Yes, okay. So you
How,
are,
how do
sorry,
how do we get this?
how do we get this? That's a good question. I don't really remember. Hmm. How do we get this really? Oh, yeah, I think it's, wait, what? You can just like do this thing. Just represent the P1, P2, P3 in vector. These are homogeneous. You have that P1 is equal to x1a, by a I mean this a, plus y1b plus z1c. Then you translate this into coordinate sort of stuff. I mean, I don't, there must be a better method, but this is the method I can think of right now. So you translate this into coordinate stuff. Like you can take a as something, y as something, z as b as something, z as something. And in the coordinate, we know that the area is given by x, y, z, x1, y1, z1, x2, y2, z2. Oh, sorry, what am I writing? There is no z in coordinate. It's given by x1, y1, x2, y2, x3, y3, 1, 1, 1. This is the coordinate thing. And so if you translate these things into coordinate stuff, you must be able to prove that. I have not really worked this out myself, so I cannot say for sure.
Wait, but
But
can't we just like say that if we convert the coordinate points into a barycentric form, like
yeah,
the ones will just become a new variable to make it
yes.
homogeneous? So doesn't it suffice to show that they're the same?
Uh, okay, I mean, sure, you can think of it that way, but that's not really true because these two things that we defined, the non-homogeneous sort of things, they are not exactly same, like they are different. I mean, they are two different systems, so you can't really combine them. I mean, there may be some way to combine. I don't really know.
Okay.
So but like it's not that this x comma y comma z you can just translate into Barry x comma y comma z. I mean, not as far as I know. Yeah, but this should probably work. You just like take coordinate stuff and translate into coordinate and work. There must be surely a better method, but I can't think of this right now. If anyone has any better method, they can share.
Okay, so one for this thing, I think I had a proof which was like you fix 2 points, and then for the other point you prove that it has to be like it has to be linear. It has to be additive, the function.
Wait, can you repeat? Which
Like
function
you
are you
fix
proving?
P1 and P2,
Yeah.
and then for P3, you say that if like you have that it's an additive function of P3. That's a linear function of P3.
Oh,
So like you prove it's
the
additive and you prove that scaling and all works out.
yeah. Okay.
And
And then
then I guess you just need to prove it for the three basis vectors are like 1 0 0 0, 1 0
Ah,
0 0
yeah,
1.
yeah. Yes, yes. That makes sense. That makes sense. Okay, did everyone get what she said? Yes, that actually makes much more sense. That is much more intuitive than this, obviously. Yeah, so you fix P1 and P2, you vary P3, and like if you just define this, it's a fix P1, P2, if you define it as a function P3, P3, then you show that f is additive, scaling, etc., etc., and then you, I mean, just show f is, uh, this is, I mean, scalable. It's bad handwriting. And then you just show for ABC. That is very nice. I did not know this before. Okay, so let's move on to the problem. So I just wait for some time till people have tried. If anyone has any ideas, you can just speak. Okay, one thing I've assumed here is symmetry. I am not really sure how do you show that it should be symmetric, but I have still assumed.
I guess actually, well, since each of the ones must have exactly 1/4 of the area, so then we actually know the altitudes from y, x, y, and z.
Yeah. Oh yeah, then they must be symmetric. That is correct.
Yeah, but I'm not sure if we can how we get symmetry in the other one because we only got one of the coordinates.
I think that you will get by the equilateral triangle, because in the barycentric mesh, as far as I remember, you don't require this is equilateral. So you should require equilateral for this to be for the symmetry thing. Okay, so like for right now, we'll just assume. Yeah, go on.
For like
Uh,
this x, y, z, so does it suffice to like prove like the vector, what do you say? The vectors x, y, y, z, z, x are somewhat just rotations?
rotations about what?
Are just rotations of each other because they're like, what do you say? Values are the same? I don't know the perfect vector notation.
Okay, yeah, so you mean like magnitudes are the same?
Yeah.
Yeah, sure. I mean, you can show that.
And we
Like,
have like PQ squared is, I forgot that formula again. You gave it in the starting. The value
yes.
of these squares.
Yeah, okay, but I, okay, sure, you can do that. Like, you mean you want to just equate these lengths, right?
Yeah.
Yes, you can do that. What I chose to do was, you know that, so you just assume the symmetric formula for x, y, z, and then you know that this thing also has area of the 1/4 of ABC. So you just put a determinant thing and get relation. That is what I chose to do. You, I think you must be able to get by using the same thing. I mean, the formula must be the same. Formula must turn out to be the same, obviously, by what you're saying. I think we can do that as well. Yes. Okay, I just start. Let's say so what one thing we have is that BYC upon BSC. Oh wait, I should like take some better YBC upon ABC. Oh, what happened? Okay, so is equal to 1 by 4, that is like given to us. So you assume y to be 1 by 4 comma p comma q. So you basically have p plus q equal to 3 by 4. So similarly, you will get x as, so these will be just, I mean, I'm assuming symmetry, so this will be just cyclic permutations. So x will be 1 by 4 goes there, so it's like p comma q comma 1 by 4, and z will be what? Q comma 1 by 4 comma p. So these will be the things. Now what we can do is we just substitute this into the determinant
Wait,
form.
sorry, what do you take as PQ and R? I didn't.
So where is R? So this is 1 by
PQ.
4 because you know YBC upon ABC is 1 by 4, that is given to us.
Yes.
And PQ and Q are the other barycentric coordinates. Like
Okay. So just some two barycentric coordinates which can be expressed.
yeah. So these are basically the coordinates of Y. So you know 1 by 4 P and Q, I don't know for now. But I know this
Fine.
relation
Okay.
by the
Yes.
P plus Q plus 1 by 4 equal to 1.
Okay. Okay. Yes.
So now you just like solve this determinant or something. What is this? 1 by 4 P Q and okay, cyclic coordinates. Okay, wait. I'm not really interested in solving this right now. I'll just check what we get. I mean, it's like easy to solve. Okay, so if you just like simplify this and continue, like just batch this P plus Q equal to 3 by 4 sometime, then you will get PQ is equal to, wait, what was it? I forgot. Okay, PQ equal to 1 by 16. So you just solve the determinant and just like go on reducing the degree by batching P plus Q equal to 3 by 4. You will get PQ equal to 1 by 16. So basically we can also calculate P and Q individual values, but we don't really care about that. So now now we want to show that they are on the incircle. So just to find the equation of incircle, there is a good formula for yes, someone is trying to say. Okay, no. So there is a good formula for incircle which I never remember. So I'll just derive this. Okay, so note that incircle passes to the midpoint, so it will be like 1 is to 1 is to 0, 1 is to 0 is to 1, and 0 is to 1 is to 1. So you will get equations like this. This is what minus a square minus b square minus c square. Oh no, what have I written? Sorry.
Maybe that would be the 9 point circle then.
It's the same thing. It's an equilateral triangle.
Oh,
That's why I was about to write this. So this is a equal to b equal to c. So these are just the same thing. Yeah, so if you just put this thing, what do you get? Look, let's put this thing. So you get minus a square plus 2 into, what is this? U plus, no, b plus something is equal to 0. So you get v plus w is equal to a square by 2. But by symmetry, of course, u equal to v equal to w. So you get that u equal to v equal to w is equal to a squared by 4. So now you get the equation minus a square yz minus b square zx minus c square xy plus x plus y plus z into, I'll just take this square by 4 outside. It will be this whole square. Yeah, so now this is just trivial. To just substitute that 1 by 4 PQ thing. You just substitute this here. With PQ equal to 1 by 16, P plus Q equal to 3 by 4. Check that it works out. It's done. Did everyone get the solution?
Is a square equal to b square equal to c square because the reference triangle is just equilateral?
Yes, yes. These are the side lengths, right? So it's an equilateral triangle. So you just get it all equal.
Okay.
Okay, so we will. Is everyone okay with this solution? Okay, I'll take that as a yes. Okay, so now one thing to understand is that when Barry is useful. So personally, when do I like Barry? It's like conditions are like projective. That means that you have lines, intersection of lines. You have standard points. And also, even though the equation of the circle looks difficult, if circle passes through any of the vertex, then it becomes very easy. Like if the circle passes through A, I'll just let A. So if you have A belongs to circle, then no, in the equation you directly get u equal to 0. So that becomes very nice and symmetric thing. So okay, so just kind of one thing to note is that equation of circumcircle is just minus a square yz minus b square zx minus c square xy equal to 0. So this is the equation of the circumcircle. And so if it passes through one vertex, it becomes u equal to 0. If it also passes through B, then you will get v equal to 0. So that eventually turns out to be good if the circle passes through the vertices. Okay, so we'll now just see a very projective sort of problem where we can use barycentric. This is the problem. I forgot the source. What is this one? Okay, it's IMO 2012 one. I will give you some time to try or like just sketch out the proof or sketch out the bash basically, not the proof. Bash is not the proof.
We can't see the full question.
Okay. So
You like move it a bit.
yes, just just zoom out. Zoom out. Or I'll just full screen. That is better. Can you see it now?
Yes, yes.
Okay, I'll let's start doing this. So you have chess the X center, so it's -a to B is to C. You have what was it? M is 0 is to you have K1 maybe. Whatever, I think. Again, it's like okay, is everyone fine up till here? Or like, am I wrong? Just point me out if I'm wrong. I'm not very bash proof person. I think this should be fine. Now you calculate ln. So you can get the equation as Sx. Okay, S by S I mean the semi-perimeter. So just Sx is everyone okay up till here? Wait, how do I get this to okay.
Yes, and then we can compute the other one by by symmetry.
Yes, that is correct. So you can compute the other one by
So we just
symmetry.
care about computing F, and then we can say that G is symmetry by whatever.
Yes, that is correct.
So we can just compute one side. No need.
What? Yes, we can compute one side. That is correct. But have I messed up the signs anywhere? I hope not. Otherwise, it will go wrong. K is on AB, right? Okay. Yeah. Seems fine. Oh, shit. This is minus. What am I writing? Sorry. Is it correct? Oh, it's minus. Oh, wait, is the screen sharing paused? Can you see what I'm writing?
You just wrote the equation last, so I don't know.
Oh, sorry. Wait, yeah. So
Yeah.
this was like wrong, my bad. I mean, I messed up a sign. This is minus and this is also minus. So there will be some minor change here. So in the K wala part, so that is here. This will be plus. But I think so. Yeah. So this will turn out to be Sx plus S minus C into this minus S minus B. Yes, it's correct. It should be correct now. Yes, you get this thing. Now you want to intersect this with Bj. Okay. So Bj you can just like parameterize it. It should be uh, minus A is to something is to C. So what you get is Cx plus Ay, A is Z equal to 0. Now we need to solve this together. We'll just like assume something to be 1, like let's say x is equal to 1 or something. Yeah, sure. I mean, we can assume x is equal to, we can like assume x is equal to minus a or something. Yeah, we can go with x is equal to minus a. So that would imply y equal to c. Sorry, z equal to c. If you substitute that here, you will get minus sa plus s minus c into y minus s minus b into c is equal to 0. So you will get y is equal to what is this? S minus b into c plus sa by s minus c. Yes. And note that now we want to calculate AF intersection AF and BC. So we only care about the ratio B is to C ka ratio. So we only care about Y by Z ka ratio. So now Z we had was C. So you will get Y by Z is equal to Okay, is this fine with everyone? Okay, is it paused? No, it's paused.
Why do we only care about the y by z ratio?
Because we want to intersect that thing with the we want to intersect that thing with the with BC, right? So for the AF part, uh, wait, how do I say this? Um, okay, let me read. So wait, what is happening? Yeah, so if you see the question, this is in what we got right now was F, right? The F was what we calculated from these two equations. These two equations gave us F.
Correct.
And now we want to find AF cap BC.
Yes.
So AF cap, if F is, let's say, some x is to y is to z, AF cap BC is going to just be 0 is to y is to z. So we only care about this ratio. We don't really care about what is x.
Oh, yes, yes.
Okay. So what we got was S now. So we got S to be 0 is to S minus C is to C is to S minus B is to C plus SA. Similarly, you will get T. Okay, now we just like by symmetry. S minus C is to B plus SA is to S minus B is to B. Is it correct? I hope it is. Probably it is correct. I assume it is correct. Okay, so now you just want to show that M is the midpoint. So you just what do you call it? Uh, so homogenize this. So if you have S, you have the sum of that, right? So it's like S minus C times C plus S minus B times C plus SA. That gives you uh, what? Did we have a minus anywhere? I hope not. Just to check. This is plus C. And what we got was, oh, there is no minus. Okay. So this is plus this thing by this is equal to, this is just A times C plus SA. Why do I feel there should be a minus somewhere? Oh, okay, no, there shouldn't be a minus. And like, it's like fine, probably. So now what you will get is this is just S minus C by wait, let me just check this one. But what is the minus here? I can't find that. Okay, so this should be minus. I messed up a minus sign here. This should be minus, I think. We will get minus here. Then we will get minus here. But I messed up a lot. So, you will get s minus c into a minus thing. So now, okay, we are like already over time. I'll just like finish quickly. So, okay, I think like you can do the rest part. So, okay, just divide this by these things and compute the midpoint. So when you're in homogeneous form, you'll just get that midpoint is this plus this by 2, this plus this by 2, this plus this by 2. And just the coordinates of m. M is this thing. So you can just see that the coordinates of m in normal form are 0, comma, this is 2. So s minus b by a, comma, s minus c by a. So you will get the coordinates of m as this thing. Just check that they are equal to after homogeneous increase and just adding and dividing by 2, and you are done. Okay, I'll just leave it at this point because we are already a bit over time. In case you want to try questions, I'll just like tell you. It's USA TST 2008-7. Then there is Elmo SL 2013 G3, and it's
USC TSC 2008, which first question?
P7. It's like day 3 P1. And wait, there is some question from USMO 2012. I don't remember which one it is. But it basically has like A, B, C, and A dash, B dash, C dash thing. You can just like find out which question has this. It's some concurrency and collinearity sort of question. So these are some questions you can try. Okay, I hope you enjoyed the class. I'll stop here. Anyone has any questions?
Yeah, so how do you like derive the formula for the vector?
For vector meaning?
Like you said you have two barycentric homogeneous coordinates and you get the formula for the vector.
Wait, I can't understand. I'll just reshare. You can point it out.
You did somewhere near the top ish.
Just like stop me if you see.
I can't see the full top. It's shifted. Oh,
Okay. Wait, what happened? Yeah, okay, so should I scroll down or?
yeah, this one. Like on the top itself, you written the displacement vector, right?
Yes.
So like, how do you get that? What's the idea? How do you get that qx minus px, qy minus py?
I mean, that's how you would generally define a vector to be, right? I mean, if you have, let's say, like if you think in complex numbers, you have A and you have B. How would you define A, B to B? It would be just be like B minus A.
Oh, okay. Oh yeah, that way.
It's the same thing. I mean, you just like interpret it in complex sort of thing.
And
I
then
mean,
the PQ, the what do you call that again? The
what?
PQ square, I forgot.
Okay, yeah, this formula.
Yeah.
I think it's just vector bash or something. Uh, so you note that this is like, so you put all those in vector form, like you will get that P is equal to P is equal to Px A plus Pyb plus Pzc, and similarly for the Q part. And then you just subtract and note that A minus B come mod is equal to A. So probably just
Alright.
vector bash this. There must be
Okay.
some like vector formulas I don't really recall.
Fine. Sure. That's. I can like send the
Send
PDF?
this.
This
Oh
one.
yeah, sure, yes. Okay, so anyone has any more questions? Okay, I'll just stop recording there.